Hello dear students, all of you welcome to Vidyan classes. Today we will discuss solution of a system of linear equations by matrix method. Theorem on solution of a system of linear equations by matrix method. The statement is given by consider the system of equations in three unknowns. a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. The system of equations can be written as ax is equal to b has a unique solution if a determinant not equal to 0, that means a is non-singular, and the solution is given by x is equal to a inverse b, where a inverse is equal to adjoint a divided by a determinant, where a is the matrix having elements the coefficients of x, y, z. Capital X is the matrix having elements x, y, z, and the capital B is the matrix having elements d1, d2, d3. The system equations can be written as Ax is equal to b. It is the same as this. Since Ax is equal to b, A means a1, a2, a3, b1, b2, b3, c1, c2, c3. X means x, y, z. B means d1, d2, d3. By the matrix multiplication, it gives a1x, go through row 1, come down in column 1, multiply the corresponding elements and add them. a1x plus b1y plus c1z, a2x plus b2y plus c2z, a3x plus b3y plus c3 is equal to d1, d2, d3. The system of equations can be written as Ax is equal to b. This is same as Ax is equal to b. Two matrices are equal, their corresponding elements are equal. a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. It is same as this, it is also same as this. So the system of equations can be written as Ax is equal to b. Clear? This system is same as Ax is equal to b. Ax is equal to b, that implies this is equal to d1, this equation is equal to d2, this is same as d3. Clear? Okay. We have to prove x is equal to a inverse b. The solution of the system equations represent x is equal to a inverse into b. The solution of the system equations or x is equal to b has a unique solution, that is x is equal to a inverse b. We have to prove x is equal to a inverse b. Given determinant of a not equal to 0, that is a is non-singular. So a inverse is exists. A inverse is exists. Since a is non-singular, a inverse is exists. We have to prove x is equal to A inverse B. Ax is equal to B. Which implies as A inverse into Ax, which is same as A inverse Ax is equal to B. Since Ax is equal to B, multiplying A inverse both the sides, since A inverse is exists. A is non-singular, which is same as A inverse A into X. A inverse B. Since A into BC is equal to AB into C. That means matrix multiplication is associative, which implies as I into X is equal to A inverse of B. Since A inverse into A is equal to I, which is same as A inverse. I is the unit matrix or identity matrix. I is the identity matrix. A inverse into A is equal to I, which implies as X is equal to A inverse B. Since I into X is equal to X into I is equal to X. Clear? Therefore, Ax is equal to B implies as capital X is equal to A inverse into B, where capital X is the matrix having elements X, Y, Z. Hence proved. Hence proved. Clear? Clear? Okay. Write down. Next, solution of the system of equations solution of the system of equations Ax is equal to B is given by capital X is the matrix is equal to A inverse B, where A inverse is equal to adjoint A divided by A determinant into B, which is same as adjoint A into B divided by A determinant. A inverse is equal to adjoint A divided by A determinant, which is same as adjoint A into B divided by A determinant, and A determinant not equal to 0. From the theorem, we have the solution of the system equations. Ax, it is the system of equation. Ax is equal to B is given by x is equal to A inverse B. A inverse is defined by A inverse is given by adjoint A divided by A determinant into B, which is same as adjoint A into B divided by A determinant A not equal to 0. First note 1. The system equations has a unique solution if A determinant not equal to 0. The system equations has one and only one solution, that means unique solution, if A determinant not equal to 0. That means A is non-singular. If A is non-singular, then the system equation has one and only one, that is unique solution. Note 2. The system of equations has infinite number of solutions if adjoint A into B is equal to 0 matrix. 0 matrix and A determinant is equal to 0. Since 0 by 0 is any number, the system equations has infinite number of solutions if adjoint A into B is equal to 0 matrix and determinant of A is equal to 0. 0 by 0 is any number. So the number of solutions is infinite. Or we can say the system equations has infinite number of solutions if adjoint A into B is equal to 0 matrix and A determinant is equal to 0. 0 by 0 is any number, so the number of solutions is infinite. Note 3. The system of equations has no solution if adjoint A into B is not equal to 0 matrix. and A determinant is equal to 0. The system of equations has no solution if urgent A into B is not equal to 0 matrix and determinant of A is equal to 0. Since K by 0 is infinity, K not equal to 0. Infinity is not a solution. The numerator is not equal to 0, but the denominator is equal to 0. That means it takes the form of K by 0, K not equal to 0, the denominator is 0, it approaches to infinity. Infinity is not a solution. So the system of equations has no solution if adjoint A into B not equal to 0, that is 0 matrix, and determinant of A is equal to 0. Clear? Clear? Okay, write down. Next, example 1, solve the system of equations by matrix method. The equations are x plus 2y is equal to 1, 3x plus y is equal to 4. Solution. Given x plus 2y is equal to 1, 3x plus y is equal to 4. Which implies this matrix having elements 1, 3, 2, 1 into matrix having elements x, y is equal to matrix having elements 1, 4. The system of equations can be written as this form. By the matrix multiplication rule, 1 into x, that is x, 2 into y, that is equal to 2y. Next, 3 into x, that is 3x, 1 into y, that is y. The left hand side is a matrix having elements x plus 2y, 3x plus y is equal to 1, 4. Two matrices are equal. Their corresponding elements are equal, so x plus 2y is equal to 1, 3x plus y is equal to 4, which is same as this and this. So the system of equations can be written as in this form. Clear? Which implies as Ax is equal to B, where A is the matrix having elements 1, 2, 3, 1. X is the matrix having elements x, y. And B is the matrix having elements 1, 4. Clear? Next, A determinant is equal to 1 into 1, that is 1 minus 6, which is equal to minus 5, not equal to 0. Implies yes, A inverse is exists, that is A is non-singular. The inverse of A is exists since A is non-singular, that means determinant of A not equal to 0. It is equation 1 implies x is equal to A inverse into B. It is equation 2. A inverse is equal to adjoint A divided by A determinant. Since A not equal to 0, A inverse is exist. Adjoint of A is given by matrix having elements 1, 2, 3, 1. Add the adjoint of A. It is a matrix of order 2. So we can find out its adjoint by the direct method. That means place interchange of the diagonal elements. 1, 1. Sign change of the elements, that is 2 and 3. It is minus 2, it is minus 3. Clear? Implies A inverse is equal to adjoint A divided by A determinant, which is equal to matrix having elements 1, minus 2, minus 3 and 1 divided by A determinant. A determinant is given by minus 5. Equation 2 implies this. Capital X is equal to A inverse into B. It is given by minus 1 by 5. Matrix having elements 1, minus 2, minus 3, 1 into B. Into B. What is B? Matrix having elements 1, 4. Minus 1 by 5. By the matrix multiplication rule, 1 into 1, that is 1, minus 2 into 4, minus 8, minus 3 into 1, that is minus 3, 1 into 4, that is 4. Implies this. What is X? X is the matrix having elements X, Y. Clear? The right hand side minus 1 by 5. It is minus 1 by 5, minus 7 and 1, which is equal to 7 by 5 minus 1 by 5. Capital X is the matrix having element X and Y. The right hand side is 7 by 5 and minus 1 by 5. Clear? Okay. Which implies two matrices are equal if the corresponding elements are equal. X is equal to 7 by 5 and y is equal to minus 1 by 5. Is the solution. Therefore, xy is equal to 7 by 5, 1 by 5 is the solution of the system of equations. Are you clear? Okay. Write down. Next example 2. Solve the system of equations by the matrix inverse method. The system of equations can be written as x minus 2y is equal to 3, which is same as x minus 2y plus 0z is equal to 3. 3x plus 4y minus z is equal to minus 2. 5x plus 0y minus 3z is equal to minus 1, which implies this. The system equation can be written as Ax is equal to B, where A is the matrix having elements 1, 3, 5, minus 2, 4, 0, minus 2, 4, 0, 0, minus 1, minus 3, 0, minus 1, minus 3. Capital A is the matrix which represents the coefficients of xyz. X is the matrix having elements x, y, z. And B is the matrix having elements 3, minus 2, minus 1. The system equations can be written as Ax is equal to B, where A is the matrix having elements the coefficients of xyz, X is the matrix having elements xyz, and B is the matrix having element 3, minus 2, minus 1. A determinant is equal to determinant having elements 1, 3, 5, minus 2, 4, 0, 0, minus 1, minus 3. Apply. C2 is replaced by C2 plus 2 times of C1. A determinant is equal to determinant having elements 1, 3, 5, minus 2 into 2 times of 1, that is equal to 0. 4 into 2 times of 3, that is equal to 10. 0 plus 2 times of 5, that is equal to 10. It is 0, minus 1, minus 3. Which is same as expanding along row 1, since row 1 contains maximum zeros. 1 into 10 minus 3 minus 30 plus 10 is equal to minus 20, not equal to 0. Since A determinant not equal to 0 implies A inverse is exist. It is equation 1. Equation 1 implies x is equal to A inverse B. Since A determinant not equal to 0, that means A is non-singular. If A is non-singular, A inverse is exist. Now we have to find out A inverse. Cofactor of the matrix capital A11, represent the cofactor of the element of first row and first column. Its sign is positive. Determinant obtained deleting first row and first column. It gives minus 12 minus 0 is equal to minus 12. A12, cofactor of the element of first row and second column. Deleting this row and this column, it gives minus 9. Its sign is negative. Minus 9 plus 5 minus 9 plus 5. That is minus 9 plus 5 is equal to minus 4, minus of minus 4, that is equal to 4. Minus 9 plus 5, that is equal to minus 4, and its sign is negative. Negative, negative, positive. A13. A13, element of first row and third column. It gives 3 into 0, that is its sign is positive. 0 minus 20 is equal to minus 20. 0 minus 20. A21, cofactor of the element 3. Deleting this row and this column, it gives minus 2 into minus 3. Deleting this row and this column, 6 minus 0. Its sign is negative. 6 minus 0, 6 minus 0, that is equal to minus 6. A22. Its sign is positive. Deleting second row and the second column, it gives 1 into minus 3, that is minus 3, minus 3, minus 0. Deleting second row and the second column, second row and the second column. Deleting second row and the second column, it gives 1 into minus 3, that is minus 3, 5 into 0, that is equal to 0, it gives minus 3. Clear? 1 into minus 3, that is minus 3, 5 into 0. Deleting first, second row and the second column. A 2, 3. Its sign is negative. Deleting second row and the third column. Second row and the third column. This and this. 1 into 0, that is equal to 0. Plus 10 is equal to minus 10. A31. Element of third row and the first column. It is the element of third row and the first column. It gives its sign is positive. Minus 2 into minus 1, that is equal to 2 minus 0. That is equal to 2. A32. Its sign is negative. Deleting third row and the second column. 1 into minus 1, that is minus 1. Minus 1 minus 0, that is equal to 1. A33. A33. Element of third row and the third column, it gives 1 into 4, that is equal to 4. 4. Its sign is positive. 4 plus 6 is equal to 10. Clear? These are the cofactors of the elements of the matrix capital A. Cofactor matrix. Cofactor of the matrix capital A. It gives minus 12, 4, minus 20. Minus 6, minus 3, minus 10. 2, 1, 10. Cofactor of the matrix capital A. Minus 12, 4, minus 20. Minus 6, minus 3, minus 10. 2, 1, 10. Implies S adjoint of the matrix A, that is transpose of the cofactor matrix. Transpose of cofactor matrix. Minus 12, 4, minus 20. Transpose, that means rows changes to columns and the columns changes to rows. Minus 6, 2. Minus 3, minus 10. 2, 1, 10. 2, 1, 10. Rows changes to columns and the columns changes to rows. It is equation 1, it is equation 2. Equation 2 implies capital X is equal to A inverse into B, which is equal to adjoint A divided by A determinant into B, which is same as A determinant minus 1 by 20 into adjoint A minus 12 minus 12 minus 6 2 4 minus 3 1 minus 20 minus 10 into B B means 3 minus 2 minus 1. 3 minus 2 minus 1. Which is same as minus 1 by 20 multiplying this matrix and this matrix. Go through row 1, come down in column 1, it gives minus 36 minus 12 into 3 plus 12 2 into minus 2 4 into 3 12 minus 3 into minus 2 that is 6 1 into minus 1 that is equal to 1 minus 1 minus 20 into 3 minus 60 plus 20 minus 10 minus 60 minus plus 20 minus 10 which is same as minus 1 by 20 10 minus 10 minus 26 10 minus 30 plus 10 minus 26 it is 17 it is minus 50 which is same as 13 by 10 26 by 13 by 10 minus 17 by 20 and minus plus 5 by 2 plus 5 by 2 x is equal to 13 by 10 minus 17 by 20 5 by 2 which equal to which implies as capital X means matrix having elements x, y, z is equal to 13 by 10 minus 17 by 20 5 by 2 implies as x is equal to 13 by 10 y is equal to minus 17 by 20 z is equal to 5 by 2 therefore xyz is equal to 13 by 10 minus 17 by 20 5 by 2 is the solution of the system of equations. Is the solution of the system of equations. x is equal to 13 by 10, y is equal to minus 17 by 20, and z is equal to 5 by 2 is the unique solution. Is the unique solution of the system of equations. Are we clear? Okay, write down. Example 3, solve the system equations by matrix method. Solution. The system of equations are given by x minus y plus z is equal to 4, 2x plus y minus 3z is equal to 0, x plus y plus z is equal to 2. These are the system of equations, which implies capital AX is equal to B. The system equations can be written as X is equal to B. It is taken as equation 1, where A is the matrix having elements 1 to 1. Minus 1, 1, 1. Minus 1, 1, 1. 1 minus 3, 1. 1 minus 3, 1. X is the matrix having elements x, y, z. B is the matrix having elements 4, 0, 2. A determinant is equal to determinant having elements 1, 2, 1, minus 1, 1, 1, 1, minus 3, and 1. Applying C2 is replaced by C2 plus C1. C3 is replaced by C3 minus C1. C3 minus C1. A determinant having elements 1 to 1. C2 is replaced by C2 plus C1. 1 plus 1, that is 0. 2 plus 1. 1 plus 1, that is equal to 2. C3 is replaced by C3 minus C1. 1 minus 1, that is equal to 0. Minus 3, minus 2, minus 5, minus 3, minus 2, minus 5, 1 minus 1, 0. Expanding along row 1, A determinant is equal to 1, its sign is positive, 0, 0 plus 10, which is equal to 10, not equal to 0. Implies this A determinant not equal to 0. A inverse Eg exists. A is non-singular. So A inverse Eg exists. Equation 1 implies x is equal to A inverse into B. It is taken as equation 2. Cofactor of the element of first row and first column. That means cofactor of 1 which is equal to, its sign is positive. Deleting the first row and the first column, it gives 1 plus 3 that is equal to 4. 1 plus 3 equal to 4. 1 plus 3. A12. Its sign is negative. Deleting the first row and the second column, 2 plus 3 that is equal to, deleting the first row and the second column, it gives 2 into 1 minus of minus 3 that is equal to 2 into 1, 2 plus 3 is equal to minus 5. A13. A13. Deleting the first row and the third column, 2 minus 1 that is equal to 1. 2 minus 1 that is equal to 1. A21. A21. The element of second row and the first column, deleting this and this, it gives minus 1 minus 1. Its sign is negative. Minus 1 minus 1 that is equal to 2. Deleting the second row and first column, it gives minus 1, it gives minus 1, its sign is negative, so the result is positive. A22. Its sign is positive. Deleting the second row and the second column, it gives 1 minus 1 that is equal to 0. 1 minus 1 that is equal to 0. A22 means second row and the second column, second row and the second, it gives 1 minus 1. Next, A23. A23. Its sign is negative. A23. Deleting the second row and the third column, it gives 1 plus 1. 1 plus 1 minus 2. Deleting the second row and the third column, 1 minus of minus 1 that is plus 1. The result is minus 2. A31. Its sign is positive. Deleting the third row and the first column, it gives 3 minus 1. 3 minus 1 is equal to 2. Deleting the third row and the first column, it gives 3 minus 1 is equal to 2. A32, its sign is negative. Deleting the third row and the second column, it gives minus 3 minus 2. Minus 3 minus 2 is equal to 5. Minus 3 minus 2. Minus 3 minus 2. A33. A33. Its sign is positive. Deleting the third row and the third column, it gives 1 plus 2. 1 plus 2 that is equal to 3. These are the cofactors of the elements of matrix A. These are the elements cofactors of the elements of matrix A. Cofactor matrix of capital A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 is equal to 4 minus 5, 1. 4 minus 5, 1. 2, 0 minus 2. 2, 0 minus 2. 2, 5, 3. 2, 5, 3. Adjoint A. Adjoint A. Transpose of the cofactor matrix. Transpose of 4 minus 5, 1. 2, 0 minus 2. 2, 5, 3 is equal to 4 minus 5, 1. 4, 2, 2. Rows changes to columns, columns changes to rows. 2, 0 minus 2. 2, 0 minus 2, 2, 5, 3. 2, 5, 3. Transpose of the cofactor matrix is called the adjoint. A transpose. A transpose. Sorry, A inverse is equal to adjoint A divided by A determinant, which is equal to 1 by 10 into 4, 2, 2. Four, 2, 2. Minus 5, minus 5, 0, 5. 1 minus 2, 3. A inverse. Equation 2 implies this. Equation 2 implies this. X is equal to A inverse. That is 1 by 10 into matrix having elements 4, 2, 2. Minus 5, 0, 5. 1 minus 2, 3. Into B. B means matrix having elements 4, 0, 2 is equal to 1 by 10 by the matrix multiplication rule. Go through row 1, come down in column 1, 16 plus 0 plus 4. Minus 20 plus 0 plus 10. 4 plus 0 plus 6 is equal to 1 by 10. 20 minus 20 minus 10 and 10. X is equal to x is equal to 1 by 10 minus 20 minus plus 20 minus 10 and 10, which implies x, y, z is equal to 1 by 10 into 20. If a scalar is multiplied with a matrix, then it will be multiplied with each element of the given matrix. 1 by 10 into 20, 2 minus 1 and it is 1. Implies x is equal to 2, y is equal to minus 1, z is equal to 1. Is the solution of the system of equations. Therefore, xyz is equal to 2 minus 1, 1 is the solution of the system of equations. X equal to, y is equal to minus 1, z is equal to 1 is the solution of the system of equations. XYZ satisfies or not. X equal to, y is equal to minus 1, z is equal to 1. 2 plus 1 plus 1, that is equal to 4. Satisfies the first equation. 2 into 2, 4 minus 1, that is 3 minus 3 equal to 0. Satisfies the second equation. X equal to, y is equal to minus 1, z is equal to plus 1. Minus 1 plus 1 cancel, that is equal to 2 is equal to 2. Satisfies the third equation. XYZ satisfies the system of equations. Therefore, x equal to 2, y is equal to minus 1, z is equal to 1 is the unique solution of the system of equations. Are we clear? Okay, write down.